This is the second video on Chapter 40, Separable Differential Equations, and in this video we will do Part C of Example 245. So we start with the equation. The derivative of y with respect to x is equal to negative y squared minus 2 divided by 2xy. The initial conditions are x is greater than 0 and y of 1 is equal to 2. So we start with our equation, and now we manipulate this so that we have the y terms on the left and the x terms on the right. I chose to put the 2 on the left. This will make the next step a little bit nicer, and to factor out a negative 1 and leave that on the right. So we have this equation, and we apply the integral operator to both sides. We find an antiderivative of this term, and it is simply natural log of absolute value of y squared plus 2. That's why I chose to leave the 2 here. It made finding this term a little bit easier. And then we find an antiderivative of negative 1 divided by x. That's going to be negative 1 times natural log of absolute value of x. We're adding our constant c, but we're going to solve for c using our initial condition y of 1 is equal to 2. This means when x is equal to 1, y is equal to 2. So we substitute x equal 1 for x right here, and then we substitute 2 for y. So we have natural log of 6 is equal to negative 1 times natural log of 1 plus c. Natural log of 1 is 0, so that means c is equal to natural log of 6. Now on this step, I've rewritten this equation here, leaving the absolute values out. Why? Because the absolute value of y squared plus 2 is y squared plus 2, and for x, one of our initial conditions is that x is strictly greater than 0. Since x is strictly greater than 0, the absolute value is redundant, so I took that out here. So now we have our equation, natural log of y squared plus 2 is equal to negative 1 natural log of x plus 6. By the properties of natural log, this is natural log of 6 divided by x. And so remember, the natural log function is 1 to 1. So that means if natural log of y squared plus 2 is equal to natural log of 6 divided by x, then y squared plus 2 is equal to 6 divided by x. Another way to think of this is apply the exponential function to both sides. E to this power is equal to e to this power, which means that e to this power is y squared plus 2, e to this power is 6 divided by x. So we have the solution to our equation. We can multiply through by x and rewrite it like this if we like. And so we have the solution to our differential equation with the given initial conditions.